Okay, so in this video, I would like to use the potential outcome framework to let you know what kind of causal effect you can get when you use the sharp RD design. And I will use this paper as an example, try to go through the key concept of sharp RD design. And this paper tries to examine the effect of legal access to the alcohol on mortality. And in US, when your age is beyond 21st years old, you can legally drink alcohol. And so that means if you drink alcohol after your 21st birthday, basically it's legal or there's no punishment. But if you drink the alcohol before the 21st birthday, it's not legal. So this paper try to use want to know how does this policy, this legal access to alcohol, how does this affect young people's mortality rate? Okay. So again, we have several concepts we need to define. First is the treatment. And here, the treatment is determined by the assignment variable. In RDD design, it's determined by the assignment variable called X. So whether the assignment variable is above cutoff C or not, that will determine the individual whether they get the treatment or not. So the threshold, or sometimes we call cutoff for the treatment assignment, is called C. So here the treatment variable is called D, is a dummy indicating whether the individual I received the treatment or not. So if they receive the treatment, that means the assigned variable is above the cutoff, you get a treatment. And if the assignment variable, the X, is below to the cutoff, you do not get a treatment. So in the alcohol example, if your age is above 21st years old, you can legally drink alcohol. So you get a treatment for sure. And if your age is just before the 21st birthday, you cannot legally drink alcohol, so you do not get this treatment. So here the treatment is legally access to the alcohol. Okay. So in RD design, whether you get a treatment or not is determined by the assignment variable, whether the assignment variable is above cutoff or below the cutoff. So depends on whether you get a treatment or not. You can define different the potential outcome. So in the alcohol case is potential mortality rate. Okay, the potential probability to die, something like this. So Y1 is the potential outcome for an individual I if he received the treatment. Okay, so 1 means you get treatment or not. So this is the hypothetical outcome if they get a treatment. So that means, so in our alcohol case is the hypothetical mortality outcome if this guy can drink alcohol legally. Oh, that means after the 21st birthday. And Y0 is another potential outcome, means this guy does not receive any treatment. So Y0 means the outcome if they do not get any treatment. So in alcohol example is the potential hypothetical mortality situation if this guy cannot drink alcohol legally. This outcome will be realized. So observed outcome again is depending on whether you get treatment or not get a treatment. If you get a treatment, Y1 will be realized. And if not, Y0 will be realized. So just either one will be realized. Okay. So in this RD design is if you above the cutoff, you get a treatment, so Y1 realized. If you just below the cutoff, Y0 will be realized. So alcohol example means if you are 21st birthday, after 21st birthday, the potential outcome if you can drink alcohol legally will be realized. And if you not, if you just be before the 21st birthday, another Y potential outcome will be realized, the Y0. If the potential mortality if you cannot drink alcohol legally, such mortality outcome will be realized. Okay. So ideally, the thing we want to do is we want to get the average treatment effect. So that is, on average, we want to compare the people if they can drink alcohol legally or if they cannot drink alcohol legally. So on average, the mortality is the difference in these two situations mortality. That can very useful. We want to know this. But the problem is, again, in this course, we emphasize this again. It is impossible to observe two potential outcomes at the same time. We either know they can drink alcohol legally or they cannot. So either they get treatment, potential outcome with treatment will be realized, or not. Potential outcome without treatment will be realized. So we need to try to recover the thing we cannot observe, the counterfactual. So RDD design suggests we can just investigate the behavior of the outcome around the cutoff. We use the outcome around the cutoff to represent the counterfactuals. So and that will basically suggest we just compare the people whose age are very close to the 21st birthday. So this epsilon is very close to 0. That means they just above, just 1 day after or 1 week after the 21st birthday. So we compare these people's their potential, their observed outcome, the mortality rate, and with who can serve the good counterfactual for those who can drink alcohol legally. That is the people whose age just below, just minus 1 epsilon. Epsilon is very small, just below the 21st birthday. So that means just maybe a few days before 21st birthday. These people, their age are very similar to the treatment group, to the people who can drink alcohol very legally, but they cannot due to this law. So we can use their mortality rate as the counterfactual outcome for those people who just above the 21st birthday, 21st years old. Okay. So later, we will show that under certain assumption, these two difference, the observed outcome between the people who just above the cutoff, who just below the cutoff, the difference actually can help us to identify the average treatment effect at cutoff. So that is, we can identify the average treatment effect, but not for whole population, just for the people who around 21st birthday, just around 21st years old. So basically that means using this comparison, compare the people just around the 21st birthday, their mortality rates change, can help us identify the effect of legally access to alcohol on mortality just for the people who are young, for the young people. And that also makes sense. It cannot really apply to the people who are very old, for example, 60 years old. The same data I will show that their result, you will see actually their result can only apply to the young people, not the very old or other type of people. So that's one limitation for RD estimate. RD estimate can give you very good causal effect estimation, but just for specific subgroup of people. For example, here is for just young people. But maybe that is your interest, so that's good. But sometimes maybe this estimate does not give you very good implications. That's also possible. So you just need to know what kind of causal effect you will get using this method. Okay. So how we can say this can derive to this is based on two assumptions. One assumption is called deterministic assumption. That means whether you get treatment or not is fully determined by whether your assignment variable is above cutoff or below the cutoff. So when you just above the cutoff, you get a treatment. If not, you do not get treatment. So in alcohol case is if individual's age is about 21st years old, you can get legally access to alcohol. And if the age is below 21st birthday, not get legal access to alcohol. Okay, so that means the probability of getting the treatment if you are 21st birthday is 100%. You will get a treatment. That means you will legally get access to alcohol. That's the rule. That's the law, basically. So it's 100% you get this treatment. And if your age just below, few days before 21st birthday, basically you don't get any treatment. The probability of getting treatment is 0. Okay. So that is deterministic assumption. Another assumption is very crucial. It's called the continuity assumption. That is, it just say the potential outcome y1 or y0 are continuous at the cutoff. So basically it say all the potential outcomes value does not change at the cutoff. And this basically implies, except the treatment assignment, all other confounding factors, all other determinants of the y of your observed outcome are continuous, has any discontinuity at the cutoff. So it will implies no other confounding factor also affect outcome at the cutoff. So if you find any observed discontinuity in your observed outcome, that can just attribute to the treatment assignment rather than other factors, because the discontinuity at y1 or y0 at the potential outcome is not really related to the treatment assignment, because if the potential outcome has any change, it's not related to treatment, because we compare the people who receive the same treatment. Either they receive the treatment or not receive the treatment. So any change in potential outcomes value is not related to the treatment status, because treatment status in each type potential outcomes is fixed. Either get treatment, we compare the people who all get treatment, who hypothetically they get treatment, their outcome, or the people who do not get treatment, the outcome. Okay, so this we can use this graph to show what this assumption means. It suggests the vertical axis is the potential outcome, horizontal axis is your assignment variable. So assignment variable past the cutoff, you get a treatment. Just below the cutoff, you do not get a treatment. And the continuous assumption is say all the value of potential outcome, either y1 or y0, they are continuous across the cutoff. So for y1, we can only observe when they get a treatment. For y0, we can only observe when they do not get a treatment. But what if we can suppose we can observe something with unobserved things? For example, for y1, we can also observe their value before the cutoff. So the assumptions say these should be continuous. These should be continuous over the cutoff. And also y1 is also continuous if we can observe their value for the people who just above the cutoff. But we cannot really observe. But it suggests if we can observe these y1 and y0, their value does not have any discontinuity at cutoff. So this assumption is implied anything we find for the observed outcome, the discontinuity, this discontinuity is not due to their potential outcomes value has any discontinuity at cutoff. It's just due to the treatment status, because after the cutoff, you get a treatment. So Y1 realize. And before the cutoff, you do not get a treatment. So Y0 realize. So here is Y0, here is Y1. So this discontinuity, the observed discontinuity, the discontinuity in observed outcome, the outcome we can observe is due to the treatment assignment. Due to this treatment assignment at cutoff, we generate the discontinuity in observed outcome, because above cutoff, Y1 realize. Below the cutoff, Y0 realize. And it's not due to this situation, not due to the Y1, the potential outcomes value has some discontinuity at cutoff. The continuous assumption does not allow this. And this assumption is crucial because this discontinuity for the potential outcome is not due to the treatment assignment. Because here we compare the people who are all get a treatment, their potential outcome. So both here are Y1, so have the same treatment status. And this discontinuity is due to other factor except for the treatment status. For example, other family background or other unobserved factor or observed factors. Okay. So continuous assumption is imply all other factors are continuous, are very similar around the cutoff except the treatment status. So then we can attribute to any discontinuity in observed outcome can be attributed to the treatment assignment. Okay. So based on this, we can identify the average treatment effect at cutoff. Okay. So basically, it suggests we cannot observe this, right? For the people who are 21st years old, we cannot observe Y0 because only Y1 realize. And RD suggests we can just use the people who just below the 21st years old to replace this unobserved outcome. So basically, why this can achieve is because the continuity assumption. Y0 at the cutoff is the same due to the continuous assumption is the same as the people's Y0 below the cutoff. And due to a deterministic assumption, that means the Y0 for the people who just below the cutoff, they can be realized. So we can use this realized outcome to represent this unobserved outcome. And similarly, we can use the people who just above cutoff to represent the Y1. So this basically suggests we can use the people who just above cutoff their outcome and who just below the cutoff their outcome, compare their difference, can help us to identify the average treatment effect for the people who just around the cutoff. And this is we cannot observe, but we can use this observed thing to estimate, to identify. Okay, so that's all for the potential outcome framework for the RD design.